Good morning and welcome to Synergizing Your Data, Effective Strategies for Aggregating and Reporting Across Diverse Data Silos. My name is James Vitale. I'm the Senior Solutions Architect from LACMA, and I'm here co-presenting today with my colleague Shyam Oberoi, the Director of Technology and Digital Media for the Dallas Museum of Art. So we'll begin here with part one, your data. So I'll do an overview of our topics. Questions that we'll be discussing during part one of the presentation include what is a data silo, understanding the data silos in your organization, and we'll include the questions of where, how, and accessibility to your data silos. What feeds the data for each silo? The question of data sources. Who's using the data in each of your silos? The consumers of your data. Who manages and maintains the data in each silo, so the owners of your data, and how are you accessing your data today, your data retrieval mechanisms. So the first question we want to talk about when we discuss data silos is what exactly is a data silo and how is that relevant in our organizations? So we'll begin with a simple definition. A data silo represents a collection of information that generally has a specific focus or purpose distinct from data in other silos. Some examples that are common in many of our organizations might include your DAMs, your CMS or collections management system, your ticketing platform, your CRM database, which is where you have information about your members, constituents, or the individuals that you're transacting with on a regular basis that are important to your organization, and your organization's finance management database. For those of you who are here in the room today, please raise your hand if at least one of these silos pertains to your organization. That's great. So if two or more of these silos pertain to your organization, raise your hand. Excellent. So this will be a very germane topic for all of you who are here today. I hope you'll take away something of value. So now we're going to go on to the questions of where, how, and accessibility. And Shyam's kindly provided this wonderful cartoon, which I think kind of captures some of the nuances that we run into with when we ask the question of, how do we get things into the cloud? So when we first talk about where is our data in these silos, there's typically two answers to this question in today's environment. It's common that we'll find these data silos, which we'll be showing some examples of shortly, either on-site, on-premise, so within your local data center at your organization, or in the cloud. And we used to call this being web-hosted at somebody's data center. Now it could be a web-hosted platform like Amazon EC2, Rackspace Cloud, Windows Azure, or similar configurations are the same. Or increasingly, many of your organizations may have a hybrid model where some of your data silos are on-premise and some of them are in the cloud, in which case it makes reporting across these data silos and aggregating the information even more challenging. We'll talk about some of these scenarios. So then let's talk about the question of how. The data in your silos is also likely to be stored using one or more of the following technologies or platforms. There's no rules or reason to this. It just really depends upon the vendors, the platforms, the software that are being used to manage each of your information management systems. But some common examples that you may encounter with your data silos include the following. Relational databases, in which there are several versions here. And we can look at Microsoft SQL Server, MySQL, MariaDB. Other organizations might be using Oracle, DB2, etc. We have more commonly in the last 5 to 10 years, schema-less databases. You may have a hosted data warehouse representing some of your silos. You could even be working with flat files as a form of a data silo, including the formats that we've shown here in our examples. And then we move on to the question of accessibility. So we might understand where the silos are. We might understand how the silos are being maintained and the technology being used for them, but are they accessible to us? And what are the mechanisms that we use to access the data in those respective silos? So again, we have a few different questions that come up when we talk about accessibility to these silos. And the reason that this is an important question for us to give thought to when we're looking at silos will be more clear as we look at some of the use cases further on in our presentation today. So some of the more common ways that we can get to the data in these silos, depending upon their locations and the technologies involved, include web service APIs, direct database queries, aka SQL, flat file extracts, which most people in this room I'm sure are quite familiar with. And then we also ask the question as to whether we have real-time access to the data in our silos versus delayed access, and what impact that might have on our business processes and what our needs are. And then the difference between extracting aggregate or roll-up data from these silos versus transactional data, which is much more discrete and could serve a different purpose in some of the reporting or analytics that we're trying to accomplish in our organizations. Now here's an illustration to talk at a high level about our silos and to kind of recap a little bit about some of the questions that we've just been discussing. So in this diagram, what we're showing here is a mixture of how our data silos might hypothetically be distributed in your organization. Going back to the earlier examples, you see here depicted your DAMs, your CMS, a ticketing system, a CRM, and a finance system. These may or may not exist in your organization. There are two rows depicting some of these systems being on-site and some of these systems in the cloud. So this is a scenario where the enterprise configuration is using a hybrid model for the storage and deployment of its silos. There is no requirement that an organization follow this model. It could be that all your silos are on-premise. It could be that all your data silos are in the cloud. It could be a mixture of the two. Regardless, the question of cross-silo database reporting is still germane. The logistics of how you do it, though, will vary. There's going to be issues of performance, security, storage, etc., that have to be taken into consideration. And then I've given some examples here of the types of client access that might be taking place in each of these silos. This type of visualization is a really important key step, I believe, for each organization to go through as an exercise informing what we'll be talking about later in today's presentation in part 2, and Shyam will be introducing the topic of developing an organizational data management strategy. Every enterprise, every organization should have a clear strategy in how it wants to manage its data. And beginning with some visualization along these lines is a key first step. Let's know what our silos are, where they are, how they're being maintained, and who the users are. So that takes us to our next slide. What feeds the data for each silo? A good understanding of any organization's data involves understanding where that data comes from. So let's first ask the question, regardless of where the silos are, what are the data sources? So in the case of your DAMs, it might be departments such as photo services, the registrar's office, exhibitions, marketing, your collections management system, and others. And I've given different examples here as well. I won't read through them all. The presentation will be available, is available to all of you to download, but you can go through and look at each of these different areas. On your ticketing platform, you have inputs there such as guest services, membership, people visiting your public website, on-site transactions, etc. Again, understanding the data silos involves understanding what feeds data into the silos, and it's another contributing factor to develop an organizational data management strategy. We might be asking, what are the question marks about across the top? Let's continue. So we ask the question, who's using the data in each silo? We might know where these silos are, we might know what data is going into them, we might even know what technology is being used for each silo, but we then need to understand who are our consumers of the data in each silo. Improving our understanding of this and clearly documenting these dependencies is a key step in developing our organization's data management strategy. So let's look at our consumers. And again, it's part of going through this exercise and understanding where are the key dependencies. And this is often a surprising process because we may not realize that, oh, our CMS data is being used by finance, or our finance data is being used by the registrar. We weren't clear of those dependencies. We weren't really sure that they should be participants in certain discussions when we're developing reports or building dashboards, etc. Part of helping build better collaboration between departments and making more clear technology decisions. So at this point, I'm going to transition off to Shyam, and we'll continue.
Thank you, James. So just to continue with, along the discussion that James had started, who manages and maintains your data? You know, we've identified all of these various silos in the organization, but is it clear who's actually operationally in charge of it? So has someone been defined as the owner or the custodian of that data? And that's going to be important depending on what you're going to want to end up doing with the data. So James was talking a little bit earlier about the mix that may exist in every organization of the various data silos. This is an example from the DMA, which I thought I would bring up, that is sort of outside of maybe the traditional types of data that people think of when they think of museums, like a digital asset management system or a collections management system. So from left to right, we have our online ticketing, for example. Below that, we have TrafSys. TrafSys is our people counters. We have cameras that are set up over the doors of our entrances to collect data on entrances and exits. We have our online collection, and then we have things like Razor's Edge or our CRM. All of this data lives in different places, right? Some of it is out in the cloud. Some of it is directly accessible by our customers. Some of it is strictly internal for our own purposes. All of this information is important in some way. So how are we accessing it today? There's a variety of different ways that that organizations can access the data, and one of the use cases that I'm going to go through later on in the presentation is specific in terms of how we at the DMA are sort of trying to bring together a lot of these various strands into a unified way that we can present it to leadership to make to get a good concept of what's going on in terms of the organization. But in terms of generally how people will access their data, I mean, everyone's got reports that they run through a variety of tools. There's exports, flat file data dumps from our various systems. Some people, if you've got staff that are technically savvy, or you've got systems that are supported, can go through various APIs. And then there's lots of other business processes that are also available. But we're going to wrap up the part one, which has been a sort of like roadmap, and move into part two. So just to sum up what we've covered so far, we've talked a little bit about the various data silos. We've looked at some of the wheres and the hows behind them, the data sources that feed into those silos, the people who may consume that data, the individuals involved in managing it, and the ways in which those silos can be accessed. So before we pivot over into part two, which is talking more about strategy and use cases, we just wanted to pause, see if there's any questions so far, and if not, we will continue.
So
okay.
Any questions about the topic of silos and how those pertain to your organization, and just that concept in general?
We'll have time at the end too. Okay, so part two. What we're going to talk about is the organizational data management strategy. ODMS is not a real thing. That's something that we made up for this presentation. But everyone likes acronyms, so we got an acronym. We'll talk about some concepts, the single silo reporting versus cross-silo reporting. Concepts of ETL, extract, transform, and load, which James will be talking about. We're not going to get a lot into data architecture, but I wanted to speak a little bit about some examples of data architecture, just to give a sense of some of the complexities that are involved in this. And then I want to talk a little bit about the presentation of data, specifically analytics and dashboards. Dashboards are sort of a big topic now, rightfully so. I think there's a lot of power in them. And I'm going to talk a little bit about that, and then we'll go into some use cases, one from specific to the DMA and one specific to LACMA. I'm going to hand it back over to James.
Okay, so there's a few different core concepts that we'll talk about during our second half of the presentation here. First, let's talk a little bit about single silo and cross-silo data reporting and how that pertains to each of your organizations. So as you can see in the visualization here, single silo reporting might include the areas of reports that are built natively into your app, web reporting, mobile devices, etc. Essentially, any kind of reporting that deals with pulling from a single data source, which is our simplest kind of reporting. Cross-silo reporting, as illustrated here, involves many silos, many database types, many schemas, varied locations, and a variety of data mappings. So there's a unique set of challenges that come into play when we look at cross-silo reporting. That's going to be the focus of our discussion today. When we look into cross-silo reporting strategies, there are 3 different families of techniques that we can approach here. And today, I'll mention all 3 of them, but today we'll be focusing on just the first 2. So linked servers and views, which is a concept that really is applicable on several domains, not just one particular technology platform. Reporting data stores, and in its most mature realization, we have full-blown data warehouses. So when we talk about linked servers and views, the intention here is to take a single database instance within the environment and create linked servers illustrated by the blue diamonds in this rectangular box, which are connections to our remote data sources. Remote data sources, again, could be of many different database types. It doesn't matter whether those are Oracle instances or MySQL instances, etc. And then on that database instance, we create a collection of views that reshape or normalize the data in those sources to create a uniform presentation of that data. So in this particular strategy, the goal is to not move or transport the data that's out in those remote data sources, which may be, this is effective, more effective when your data silos are all on site and they're all adjacent to you within your local network, so that you can go ahead and create linked servers and views, not have to actually ship or move any data. And then on your reporting server, you can build a collection of reports that are built against these logical views with the appropriate permissions in place. And the advantage of this particular approach is that your data is relatively real-time and current. There could be some drawbacks in terms of performance impact. You'd have to make sure that you're building sets of reports that are performant, that you've built appropriate indexing, and take a look at whether this is going to be a useful and effective mechanism. I'm not sure where I'm getting this security warning, but we'll clear this out in a moment here. Apologize. And see if that's going to work well for your organization. The second strategy, reporting data stores, is a first step towards a data warehouse without going completely in that direction. So in this particular case, you'll see that the center rectangle has been modified to show the indicator of ETL, and it introduces a cylinder with a reporting database on it. So in this particular case, we're going to use extract, transform, and load mechanisms, which we'll get into a little more detail about in a moment, to actually schedule the extraction of data from your silos into a central data store, transform the data if needed, and keep it locally cached in this reporting database. So rather than using logical views, we're actually taking samples and extracts of the data, centralizing them in a central point of aggregation, and then building reports off that reporting database. That alleviates load off of each of the data silos respectively and improves report performance. And there's a number of advantages of this particular approach. There's also some more maintenance and administration involved, but it certainly has its merits, and we'll talk about that a bit more. Moment here. So let's talk a bit more about what that purple rectangle with ETL represents. So this concept of ETL, extract, transform, and load. Developing ETL, so the E, extract. This is the process of querying and exporting the data from its source location to a temporary intermediate location for pre-import processing. So query your data from one of the data silos and move it somewhere into an intermediate location. We transform the data if necessary. So for example, the data may be shaped or formatted in a particular way in one of the data silos, address data, phone data, membership data, etc. And we need to apply some transformations. We may need to go through some cleansing, an address cleansing process, or a phone number cleansing process, or some other transformations that are appropriate before you put it into your reporting data store, and then you do the final step of loading it. There's a very common term in the data warehousing practice, ETL, and so you'll hear it quite often, and it's important to be familiar with it. But when you're establishing a data store, even if you're not doing a full data warehouse, this is the term that you're going to hear. And so that concludes those 2 topics, and now I'm going to hand this back off to Shyam to continue on with the topic of data architecture.
Great. So depending on how you're going to set up an ETL, if you are going to set up an ETL, wanted to throw out a couple of just some examples of some of the tools that are out there that can assist with this. One of them is called Open Refine. It used to be called Google Refine. It is a fairly sophisticated tool which can be used to do all sorts of transformations on sets of data. It doesn't necessarily connect directly to your data source, but it works on that extract from that data and then can do a tremendous amount of refinements based on sort of programmatic steps to clean it up prior to processing it elsewhere. Importomatic is, a lot of folks use Razor's Edge, Blackbaud Suite. This is a tool that is not free, but is also, but is powerful for, I'm not sure what this is, to do that same sort of refinement of data specifically around your CRM, if you're using Razor's Edge. Those are sort of like some examples of simple tools that are out there. On the more complex side, we start talking about setting up a more permanent structure of middleware, an aggregation layer where you can harvest these multiple silos into a single repository. So in the example I have here where it says collections and dams, those repositories in this example would come up into this middleware layer, which can be then used for all sorts of things, not just reporting, could actually be used for live access to that content. There are challenges with this. Given the mix of data silos you have, a unified approach could be challenging. And the challenges really depend on what it is you're trying to do with it, right? Are you only trying to report on the data, which is one thing, or are you trying to actually make modifications to that data? I mean, say, rule of thumb in general, it is much easier to extract your data and consolidate it in a single place and then report on it than it is to do that same sort of thing and then write back to your source, right? The read-only option is much, much simpler than a sort of read-write, because when you're read-writing, you have to account for the changes taking place in multiple places, whereas the read-only on that ETL example, the data still exists in your source, and you're just reporting on it. You're not trying to write back to it. I don't want to talk a lot in detail about data architecture. Data architecture is a complex topic, and we could spend entire sessions talking about specific scenarios. But I wanted to show a couple of examples of some of the systems that we have set up at the DMA. This is an example for our online collection, and it utilizes some of the concepts that we've been talking about. So in the center, we have this thing that we call the brain, this box, and it essentially acts as a middleware layer where various data silos, our TMS, our friends data, our digital asset management, get harvested into a central repository. That repository itself is powered by a schemaless MongoDB, and then the brain feeds out to our online collection via an API. This diagram was done maybe about 2 years ago, and since that time we've plugged other things into it. So we have a separate process now for aggregating educational data, which is another data silo which comes into it, and then from feeding out from it, we have a mobile app, for example, which is just another application which can read the unified content that we've got available in this central middleware repository. So, and this is the example of that mobile app. Again, in this diagram, brain would sit right up there at the top, where we also have some other data sources that we're making available. Our online ticketing, for example. In the middle is AWS. So we've set all of this up, Lambda services and in Amazon. And then we have some new integrations at the bottom for analytics, things like Firebase, Crashalytics to report on crashes. Again, not going to talk about the details of this, just as an example of the types of architecture that can be set up with a unified data environment. Dashboards. Let's talk about dashboards. Everyone loves dashboards. Some examples of cool dashboards. These are not necessarily from museum sectors. The first two are. The Smithsonian has a very, very cool dashboard. You should check it out. I don't know a lot about the architecture of it, but it's very sophisticated and reports on things aside from just like their online collection. Carnegie Museums has set up a dashboard, and they've also made their code available on GitHub, so that might be worth checking out. This last one is sort of interesting. I put it up here because the code is available on GitHub. It's used by the city of LA, and it's pretty slick, and it reports on a lot of things like police response time, garbage collection. It's a metrics. It's supposed to be metrics to give an overview of the city services in Los Angeles. And the interesting thing about it, and this is the excuse me, the reason why I wanted to put it on here, is because it sort of illustrates the pros and cons of dashboards. Dashboards are great if you have a live, accurate, timely connection to your data. If you go into the City of LA's dashboard right now, I look at some of that data, it hasn't been updated since 2015. So I think that's the downsides of dashboards and reporting. It's only as good as the data sources that you have. Some other examples, these are not necessarily dashboards. Google Analytics, everybody knows Google Analytics, I don't have to talk about it. For mobile, we're using something called Firebase. It's also by Google. It's functions similarly to Google Analytics. AWS also has a mobile hub for mobile analytics. Both of these, we evaluated both of these when we were doing our mobile app project, and I can say they're both really strong solutions. And then some data visualization stuff. I'm going to talk a little bit about the specific tool that we're using at the DMA in a minute. But there's lots of them out there. Microsoft has a tool called Power BI, Business Intelligence. Google has a new tool called Google Data Studio. There are a number of players in the space. This is just some examples. So how can we access our data? When it comes to things like dashboards, when it comes to things like any sort of data visualization tools, I think the key thing is that all of them will accept a variety of sources regardless of the format. So all of that stuff that we've been talking previously about your various silos and do they sit in your institution, are they in the cloud, for any sort of mature data visualization reporting system should be able to take into account the variety of those data sources, and regardless of where they are, regardless of what type of format the data is in. And like I said, with the City of LA example, this data and the visualization and all the reports that you can do at it is only as good as the underlying sources and is only as good as the connection to those sources. If it is not a live, timely refresh on that data, you're going to be left with information that's out of date and there's no use to anyone, as I just said here. If you can't access your data, if the data is not constantly refreshed, then ... bad things happen. So at the DMA, just to sort of recap, in the real world, there's never a single solution for managing complex data sets. People have this idea, I think, sometimes of like the Swiss Army knife. If only we had this thing that brought everything together and then everything would be so easy. I don't really think that's the world that we live in, and I'm not, so I'm going to try to work with what we've got. And it could also be especially complicated if there is no API. There's a number of enterprise applications that museums use, collections management systems, donor management systems, that don't have really good facilitation for getting data in and out, and that can be especially challenging to us. But like I said, the reporting on this, or the tools that can layer over this stuff, have really improved dramatically in the last few years. So let's talk about some of those. At the DMA, we have a dashboard. This is similar to the dashboard that the IMA has or had. This is not a live feed into our data sources. This is an example similar to the City of LA, where we have a number of manual updates that are made to the various metrics that we're tracking, and then these get updated in the dashboard as these updates become available. So to put it another way, there is not a direct connection to any of these sources. Rather, we would have an extract of that data which then feeds into the dashboard. And we track a whole number of things in here. We're tracking our membership revenue, we're tracking number of objects in the online collection, number of Twitter followers, just to give a sort of broad general overview of the various state and the numbers of the museum. Another example is a tool called Chartio. Chartio is somewhat similar to some of these other data visualization tools. It is cloud-based, it is not free, you will pay for it, but you can plug in any number of data sources into it to do certain things with it, depending on what you want to do. In this case, this is actually a live data feed into our people counters. So we have cameras that are set up across the museum to count entrances and exits, and this actually feeds directly into Chartio, so our visitor services folks can go in and they can look. At the top, we see our daily attendance, and at the bottom, we actually see that attendance broken out by the particular camera. We have 3 main entrances, the north, the south, and what we call ceremonial, which is our sort of original central entrance. And all of this can get tracked, and we can break it down by how many people are coming in at each entrance. And then the last, which is what I'm going to talk most about in my particular use case, is Tableau. And since I'm going to talk more about Tableau, I will not dive into this, just to say that this is Tableau, and it is super cool. So our use case, we had challenges, we had things that we wanted to track, and we had to find out a solution for that. So let's talk about what our challenges were. When we were looking at all of this various data that we had at the DMA, we said, well, sure, we can access it. I can go in, or someone on my team can go in, and we can pull out these little bits and pieces. Somebody wants to know, what's our web traffic doing, or how many people came into the door last week, or what's our membership revenue for, this Q1, something like that. I could go and do all that. I can have somebody or people in the organization can go and do all that, but it's very ad hoc, right? And we're constantly getting asked these questions about, what's the state of this? And so we sat down and we tried to think of a way that we could sort of solve this, or at least try to organize and consolidate this. And so our challenges were, we want to be able to provide the executive staff, our leadership team, with simple, timely, accurate information around the key metrics, right? Metrics in this case being revenue, but also the things that drive revenue, such as attendance. And like I said, the information is scattered around the org, multiple formats, owned by multiple stakeholders. We've got on-site data, we've got CSV files, we've got people with clickers making counts and galleries, all sorts of stuff. Those are our challenges. So we wanted to find a way that this data we know exists, we need to find a way to aggregate it, to filter it, and to repeat. This has to be something that we can do constantly. We don't want to do all this work and just do it once. We want to do this work and do it all the time, because the data changes every single day. And we need to know, as an organization, where are we on the continuum? So defining the metrics. Like I said, we started looking at things specifically related to revenue. Probably very similar in lots of different organizations. Revenue for us is membership, so we're a free general admission, but we have paid members. We also have paid ticket sales for exhibitions, events like lectures. We have parking, we have our own garage on site, and then we have retail, we have food service. But in addition to revenue streams, we also wanted to look at some of the revenue drivers, and this is, I'm sort of loosely defining revenue drivers, but number one, general attendance, but also things like web visits, right? How many people are coming to our website? Where are they going on our website? Social media. We've got, like everybody does, Twitter, Facebook, Instagram, all of that. And also, which I'm loosely defining as what I call in-gallery digital interactions. So we do have our DMA Friends program, which is still running. We have a mobile audio guide, which has been available for a number of years, and we just recently released a mobile app. All of these numbers are interesting to us, right, in that they tell us like how often these digital platforms are being used, and how could that potentially feed into things like our revenue and attendance. So the solution that we came up with was Tableau. If you guys aren't familiar with Tableau, it is a data visualization software. We're using something called Tableau Desktop. There's a couple of different flavors of Tableau. If you're a really big organization and you're talking about petabytes of data, like really truly big data, there's also Tableau Server. If you guys are familiar with TechSoup, there is a Tableau, you can get a subscription via TechSoup at a significant discount. The software is not expensive, but discounts are available. And there is what's called a Tableau Public Edition, which is free. It's very limited, but if you wanted to sort of like dip your toe into it and play around with it a little bit, it might be a good way to get started. The thing that's good about Tableau is that it can accept an infinite number of data sources. So essentially what you do is in Tableau is you define a workbook, and that workbook can contain one or multiple data sources. So you can have, in this example, a SQL Server database that has a live connection to your workbook. You can have a CSV export that comes from some third-party cloud-based system that doesn't have an API. You can have just a flat file that has a count of a particular gallery that an attendant took with a clicker. All of these data sources can be aggregated into Tableau workbooks, and the workbook can then very easily be refreshed. Every time new data becomes available, you just click the button and you can refresh that. So that was how we brought together the data sources. We knew that some of it we had a live data connection to our database, but some of it was going to be manually submitted. So we set up a shared space in Dropbox. The DMA has a sort of enterprise Dropbox account where the various stakeholders across the organization who are responsible for managing this data can contribute their data into a single space. So then Tableau can just point directly to that space in Dropbox, retrieve that data, refresh the report. And then we have it online available internally, but then we also just generate a report. We do it every Tuesday, and we email it, and we put it up on our intranet. So this is an example of the Dropbox, and you can see we've got various folders in the Dropbox for things like attendance, box office, cafe, membership. These are where the various data streams will go into that are sort of manually brought together by folks. And then, like I said, Tableau will just looks directly into these folders in order to get the data. And then you can do cool stuff like this. I kind of had to redact some of this because we're talking about like sort of internal revenue numbers. But at the top, we have examples of gallery attendance, attendance in particular galleries. Tableau allows us to do things like projections and then track against those projections. So are we overperforming or underperforming? So this is our box office revenue projection. The blue line was what the projection was, and the red line is our actual sales. And then the last one over here is just garage, parking in the garage. So FY17 is the orange line, FY16 is the brown line, and so we can compare and contrast. And this is just an example of how we set this up in particular. It can be set up any number of ways. Some of the things that we do look at things year over year. Some of them look at our projection versus actual. Some of them are more granular than that. And this we found is a very effective way of sort of informing our executive leadership and people like our CFO, like to very quickly show them like how are we doing in these key areas. Like I said, we send it out every Tuesday. Everyone knows that they're going to get it. We also have an intranet. We use Confluence, and so we have a space set up in Confluence. All of the stuff that we've been collecting, we drop off there too. So if anybody ever wants to go back and look and see, how are we doing in a particular week, they could go back and they could look at that. And now I'm going to turn it back over to James for use case number 2.
Thanks, Shyam. Okay, so we spent some time talking about reporting and dashboards and how you can leverage that against your data silos. Now I'd like to talk a bit about data integration via APIs and how we've approached that here at LACMA. There's two specific scenarios that I'll be reviewing and showing you some of our implementations today. One of them is with our Collections Online system, and another is with LACMA's digital member card app, which we call the DMC. So let's dive right in. So in our integration with Collections Online, our implementation interacts with two data silos, specifically TMS, which is our gallery systems application, as well as our DAMS, which is currently resource-based. This implementation leverages database replication. It's designed with fault tolerance and durability in mind, and it provides near real-time content updates to our Collections Online website. So we're going to go through the pieces of this puzzle. So part one is the evolution of our data silos, and we'll kind of walk through that step by step. So in this first slide, all you see here is LACMA's on-premise data center and the TMS database. It's kind of like a little organism crawling out of the ocean, administered by LACMA's users. In slide number 2, we have the introduction of a DAMS, which is also on-premise, and this is a MySQL database. So we've gone from one data silo to two data silo. And right now, they stand independent from each other and have no interaction whatsoever. In part 3 of our evolution, we introduce one-way caching of tombstone data into the DAMS's media or resource records. So now we have a little bit of interaction between our data silos. So happens that the resource-based platform provides a plugin called TMS Link that allows it to synchronize data between the DAMS and TMS so that the resource records can have certain attributes extracted from TMS on a regular basis. So you can see in this part of the diagram, there's a little blue cylinder called TMS. It's introduced visually next to the DAMS DB just to kind of represent that it's now caching a small slice of TMS database and keeping that synchronized there. Now, as we go to part 4, we evolve into a hybrid environment where we have some data silos on-premise, TMS and the DAMS, but now we've blossomed and introduced a new data silo that's hosted in our Rackspace data center, which is a Drupal CMS database, a content management system, administered by our Web and Digital Media group. At this stage, in part 4, that particular data silo is not yet having any interaction with the on-premise data silos. Continuing the evolution, we decide that, wouldn't it be useful if our content management system could access information about our art object collection and then be able to present that online to people coming to LACMA's Collections Online website. It is after all called Collections Online. So when I started to architect this solution for LACMA back in 2011 and 2012, the first step of implementing this solution was to establish one-way database replication of our TMS database up to a sister instance up in our data center in Rackspace. And we call this the LACMA API database, which has a limited copy of our TMS database replicated up there. So that was step 1, was just to establish the Microsoft SQL database replication, one-way only, read-only, up to the cloud. Once that was in place, a couple of things then became possible. I was then able to build in these red diagram objects here APIs against both the API database that I had up in the cloud, as well as against the DAMS database hosted on premise. That allowed a couple of things to be possible. One, it was going to allow the content management system to be able to synchronize itself with collections information that was being pulled out of our on-premise collections management system, TMS. It was also going to provide the ability for our collections management system to cache images out of the DAMS. So now we're going to have 2 points of integration with data silos that existed in 2 different places. And the important thing about this implementation was that it was disconnected from the on-premise resources so that the collections management system would pull the images over and cache them and then no longer be dependent upon whether the DAMS was online or offline. In a similar way, by running off of a replicated copy of the collections management database, we weren't as dependent upon whether or not that collections management database went online or offline, or whether there's a network outage, et cetera, again, creating a bit of fault tolerance and redundancy in the architecture. So in the very last slide, bringing it all together, you can see these final hooks where the collections online system is calling out to the APIs. So in this final slide, this visualization, we have our production architecture, and this is the final picture as we build the blocks to put it all together. So that's our first use case here. And our second scenario, it's a little bit simpler. We have our digital member card application. So LACMA's goal with this situation was to give folks an app on their cell phones, their smart devices, so they didn't have to bring their printed membership card around anymore, and just hold up a digital representation of it that was on their cell phone, show it to box office, have it scanned, has a QR code on it, and get admission to the museum. So it's a read-only mobile application. It relies on interacting with our CRM data, which is currently Razor's Edge. It leverages RESTful APIs to an AWS-hosted application server. The app server leverages a local data cache, which is periodically refreshed via a flat file that's delivered to it over secure FTP. And there's an ETL workflow implemented using SQL Server integration services on our Microsoft SQL Server. So we'll go through each of these pieces step by step. So again, the very first slide here, on the on-premise data center, we have our CRM database, which is effectively Razor's Edge. And the goal was to have this DMC mobile, we have our DMC mobile app users out there in the cloud on the right-hand side. And there's no communication integration yet here on this slide. We're just laying out the basic building blocks at this point. So step one was to implement the SSIS workflow on-premise to generate this flat file. So there's a number of business rules built in there. You can think of it as a collection of SQL queries, a stored procedure, that's respecting the business rules that were defined to us by membership to say, these are the data fields, this is the data that we need to have accessible within the web-based application server to support the API calls of the mobile application. So there was an analysis process, a discussion with the different departments involved to figure out what's the data that we need to be able to extract out of Razor's Edge. And then I designed the ETL workflow to go and query that data, extract it, put it into a CSV file. So that was step one of our ETL. So we can consider that the extract and transformation process, the E and the T parts. Then implementing the second part is the secure FTP transport. So we want to make sure that we're protecting our membership data as we send it over the cloud and doing it securely. So we send that via SFTP using SSH between our place and the Amazon Cloud instance, get that up to the application server that's actually hosting the services for the web app itself. It's administered by our IS and web and digital teams. And then there is a separate developer who built a set of RESTful APIs on that particular application server which support the functions of the mobile app itself. So in this particular instance, we're dealing with a single silo, but we're building a nice, elegant ETL workflow that's complementing the set of APIs that are on the app server itself to support the needs of what we have going on for different applications. So this is another nice visualization of how each of your organizations, by understanding what's in your silos and understanding how to build workflows around your silos, can extract data from a variety of places. And you could very easily see how this same workflow using something like SSIS, which any of your organizations that are using SQL Server or have SQL Server licenses automatically have SSIS without having to pay for anything extra, can build a similar workflow that pulls from multiple silos, aggregate that data into a CSV, XML format, et cetera, and then send that off on a periodic basis to a remote destination that's hosted in the cloud, and then use that to, we happen to cache that into a Berkeley database that's hosted on the app server, for example, but use whatever technology suits your needs. So this is a second example of data integration via APIs here at LACMA. In conclusion, so we've been talking quite a bit today about a number of topics having to do with data silos, and bringing this all together, we want to circle back to this topic of an organizational data management strategy. And there's a few steps to this process that I think are useful to review at this point as we wind down the presentation and move on to Q&A. So the steps that I've outlined here are as follows. Step one, define a business activity or decision-making process that you'd like to improve or enhance through the use of cross-siloed data in your organization. So perhaps the way that you decide the type of email marketing campaign that you're going to use to target your membership. Then decide on a data organization or accessibility approach. What's the best way that we can pull data from our CRM, et cetera, and how often do we need this data? What data do we need? How do we want it delivered, et cetera. And step three, work with your IT and your technology teams to pick the tools and technologies that might best facilitate that goal. So as you've seen with Shyam's presentation, there have been a number of excellent tools that are out there, and the DMA has developed some great best practices around using them, and visualization tools, reporting tools, delivery tools, etc. Step 4, define a modest POC, proof of concept, that leverages your decisions from steps 2 and 3 and achieves the goal defined in step 1, and then move forward with that POC. We really can't know if something's effective till we try it out. So let's take our first few baby steps and see, is this viable? Does this work for us? Step 5, after launching the POC, seek feedback from multiple sources. What worked? What didn't? What were the lessons we learned? Step 6, applying these lessons, define a second POC that addresses another meaningful organizational need that your data can support. And then consider establishing a user group or a steering committee that can maintain standards, momentum, and visibility of data-driven goals. So these are just kind of a high-level set of steps to try to help your organization get its feet on the ground with an organizational data management strategy and make it feel like it's something that's attainable without feeling overwhelming. I really think it's an important thing for everyone to take a look at and consider, and there's a lot of amazing benefits that can come from it if you put some time and energy into it. So with that, I'd like to thank you all for attending, and your questions are welcomed and encouraged.
So my question is, Tableau is inexpensive, but there are other business intelligence solutions that are not so expensive. There's also a lot of soft costs involved. So if your institution isn't involved in this, what would be an example where you've had a good return on investment that I could take back to my administrative team or executive team and say, this was something that really got down to dollars and cents? That, in other words, there was positive outcomes from this for the institution that made sense for us to start down this path.
So I just want to make sure I understand your question. Is it sort of justifying the investment in the tools that would allow you to do those types of reporting? Is that what it is? Yeah. Excuse me. I will say that the startup costs for Tableau are fairly insignificant. I mean, we're talking a few $100s probably. So it's not as if it requires a massive investment in funds in order to do that. It may be sort of putting the cart before the horse. We didn't decide upon Tableau because we wanted a data visualization tool. We decided upon Tableau because we understood we needed to have a timely, repeatable process in place for easily visualizing lots of different data across lots of different areas. And so when we went through the process of looking at some of these other solutions, we settled upon Tableau. So we had already identified our problem and that we knew that we were probably going to have to devote some resources towards solving that problem. So I don't know that we needed to go out and try to justify it after the fact, because we knew in order to do the types of reporting that we wanted to do, we were going to have to make some investment in software to allow us to do that. I don't know if I'm answering your question entirely, but yeah. But I will, like I said, if it is something, and I'm not endorsing Tableau necessarily, it's something that worked for us. There are lots of other options that are out there. If you are a museum that has a partnership with Microsoft, for example, via TechSoup or via their community licensing, their Microsoft Power BI tool is available for free, right? So there's other options out there that you could get started with.
Another thing that may be useful in your organization, which museum do you work at?
The Morgan Library Museum.
Okay, so depending which groups you feel may have the most interesting use cases, so try to identify an area where there is a perceived inefficiency, where the data might help solve the inefficiency. And to Shyam's point, if there is a particular area in your organization where a report, some type of decision-making data from one of your systems would help that particular department be more efficient. Like, and let's measure efficiency in a very quantifiable way. So if you talk to a department head and find out that they're spending 20 person hours a week on X activity because they don't have an automated process to do that activity, like a report of some kind, and if you can then build a report that frees up that 20 hours, you've now quantified to your CFO the savings, which is equal to 20 person hours, by implementing that report. So if it took 40 person hours to implement that report, you've now recovered that 40 person hours in 2 weeks, in a 2 week period. And so I think that's a really measurable way for you to kind of go back into them and say, okay, and to the cost perspective, you use like SQL Server reporting services to start out with, just do a proof of concept, which doesn't, if you already have SQL Server, wouldn't cost you anything. You could do your POC, show that now you've recovered that, and that gives you the footing that you need to then go down the road and maybe pick some other implementations like Tableau or other products that maybe cost a little bit more. But you're then showing a real world example of how you recoup cost in person hours.
Yeah, that's a really good point. I mean, for us, like, we're using it to look specifically at things, like I said, revenue and revenue drivers, and that's less about, I mean, obviously, we don't expect like the reports are going to help us to drive revenue necessarily, but that we can keep track of where we are in terms of our various projections. So if we're, just to use one example, if we have an estimate for attendance on a particular exhibition, we want to know, like, immediately how we're tracking against that over the life of the exhibition, and we don't necessarily want to wait till the end of the exhibition to figure out that we're underperforming. So that if we do see that we're underperforming based upon our projections, then we can go and we can look at things like other ways that we can incentivize audience to come to the exhibition, whether that's from marketing spend, whether that's promotions, a 2-for-1 discount, whatever, right? But I think that, yeah, it's a really good point. Other questions?
In your respective organizations, what are the staff resources allocated to providing and maintaining your various solutions? What does that structure look like?
I'll go first. So for us, we have an evaluator who's on staff, and his job is primarily to do all sorts of evaluations. So he'll do in-person surveys of our audience, SurveyMonkey evaluations, but also is tasked with keeping track and doing projections for all of the museum activities. So we'll have a projection for general attendance for the year, for an exhibition, working with other stakeholders like in the store or membership in terms of what their projections are for the year and how they're tracking on that. But all of that, he's sort of the one who sits in the center of that activity, and he's the one, so in my example where all the various data goes for our executive reports, he's the one who is responsible for using Tableau and aggregating that content, setting up the workbooks and pushing it out. So he relies on a number of other people across the organization, but he's the person who's responsible for all of that. He's not responsible for the technical upkeep of the systems, right? It's a whole separate thing. But so it's one person in our place who does other things as well.
So within our IS department, we have a director of user support infrastructure who is responsible for the physical infrastructure behind the technology systems that you saw outlined. My full-time job is solutions architect, so I do our actual software development implementations. I support all of the different things that you saw described in the use case solutions that are up there as well. As far as requirements gathering and analysis, that is a shared role between different business units. So whether it's our membership team, development, box office, I'll often work collaboratively with folks in those departments to help distill out what their requirements are. So whether it's for a new report or support a new application, that's a collaborative role between different departments. So I'll often find myself working as a facilitator or mediator in that respect. And then we have a few other folks who coordinate other aspects of our internal operations, whether it's help desk support or application support on the desktops and things like that. We have a total of about 5 or 6 people full-time in our IS group, and then a separate group for web and digital media.
I think we're coming up to the end, so thank you very much for attending.